the last thing we're going to look at in this latest section on calculus is what we call the primitive function. You may remember when we started doing calculus, it was to answer a question, and that question was, how do we find the equation of a tangent when all we know is 1 point on the curve? Primitive function now takes that question but asks it the other way around, and that is, well, how do we find the equation of the curve if all we know is the equation of the tangent? So how do we go back the other way? Now, it's what's called the primitive function. If we think about it logically, to get the equation of the tangent, we differentiated. And when we differentiated, we brought down the power and subtracted 1 from the power. Logically, if we're going back the other way, instead of subtracting 1 from the power, we should add 1 to the power. And instead of multiplying, we'll divide. And I guess the easiest way of checking this is, well, if I was to ask you to differentiate this expression, x to the n plus 1 on n plus 1, you'd bring down the power, n plus 1, which would cancel with the denominator. You'd subtract 1 from the power, x to the n, and sure enough, you'd get the derivative. It's alright. We know the derivative is 3x to the power of 4. So all we have to do is add 1 to the power and divide by that new power. 3x to the 5 on 5, but that's not enough information. And that's why I've got plus a constant there. Because remember, when we differentiated a constant number, what did we get?
0.
So therefore, if I'm going back the other way, how do I know I haven't got a constant there? Because the 0 could have become a constant. So unless they give me more information, like a point on the curve or something like that, best I can do is say, well, it could be plus some constant. And just like we saw with differentiation, if we have several terms, we'll just do 1 at a time. So the 6x cubed, add 1 to the power, 4 over the power. 5x squared, add 1 to the power, 3 over the power. X, add 1 to the power, x squared over the power. And then 2, well, that's really 2x to the power of 0 if you think about it. So add 1 to the power, we get 2x. But again, plus of course there could be a constant there that we don't know about. So tidying that one up, cancelling the fractions down, we get our possibility for the function. Right. So how do we solve the problem completely? We now know that the curve passes through the point 1, 1. It has a gradient function of 2x plus 3. A gradient function. Well, what on earth are they talking about? Yeah. Because remember, the derivative was the function that allows you to find the gradient. So another name for it is the gradient function. So they're basically telling us that the derivative is 2x plus 3. So I'll add 1 to the power. Over the power, I get x squared plus 3x plus some constant. But this time I've got that additional piece of information. I've got that it passes through the point 1, 1. So I can substitute in and work out that the constant is negative 3 for this problem. So therefore, we get y equals x squared plus 3x minus 3. That is the original curve that we would have started with. So 10J is playing with this idea of how do we get back to the original or the primitive function.